In today's video, we're starting a new series where we build the BitaxeHex with 6 BM1366 chips. This little miner should push somewhere between 2.7 and 3.3 terahashes per second, while only using about 57 to 65 watts. I needed to design a 3D printed jig for my stencil. It's a simple design with 4 bolts on each side so I can adjust the stencil when it's in place. I just cut the stencil to size and install it in my 3D print. I have one jig for each side of the board. Then I do some fine adjustments with the screws, and voila, I can start applying the paste. Before we can solder the ASICs and the ESP32 to the board, we need to prep them first. I think it's called tinning the pins. Basically, we want all the pins already covered with solder. So I put the chip in a small vise, and I'm really careful not to tighten it too hard, otherwise I'll just destroy the ASIC. Then I add a bit of solder paste along the pins and some extra flux, and gently run the iron so all the pins get a nice thin layer of solder. You can see the color change from gold to silver when it's done. After that, I take some wick and clean up the excess paste. This part is really important. We need all the pins to be tinned and at about the same height, and also the big middle pad needs to be flat. That way, when we solder the chip to the PCB, all the pins and the center pad will connect properly in one go. Now I'm putting the PCB into the stencil jig and gently aligning it with the side screws. I'm taking all the time I need here, because if this is not lined up properly, I will regret it later when SMD components start merging together or not soldering to their pads. Trust me, if you rush this part, you will regret it. This is one of those steps where going slow actually saves you a lot of pain later. This video is sponsored by Next PCB, the manufacturer of the BitaxeHex PCB I'm using today. They offer really competitive prices and a super easy quoting and ordering process. All you need to do is upload your manufacturing files, the Gerber files in the upload section, and you're basically done. Then you can choose options like thicker traces, special finishes, and even order a stencil for the thermal paste, which is really useful. They also provide the HQD FM free Gerber viewer and DFM analysis tool. You can use it to view your design and run some analysis before ordering. If you're planning on making any PCBs, please check them out using the link in my description. Thanks for your support, and thanks to Next PCB for sponsoring this video. Okay, now I'm putting the SMD parts in place. I'm using the iBOM.html file that you can download from the GitHub repo. It's a really helpful tool. It highlights the parts on the board, and you can just follow the index without worrying too much about the part IDs. It makes life a lot easier. I start with the ASICs, then the ESP32, and after that I just follow the iBOM for the rest of the small components. The bigger parts, like the headers, the USB-C connector, the big coil, and the large capacitors will be placed later, because I don't want them in the way when we flip the board and work on the other side. Now I start with the heat gun. I usually have it set to around 350 degrees Celsius, and I begin reflowing everything. I'm having a lot of trouble with this board, and that's pretty normal. This PCB has 4 layers, and 2 of them, the middle ones, are big ground and power planes. They're made this big for several reasons: easy access to power and ground, better heat spreading, noise, and interference reduction. But the downside is, because there's so much copper, the board takes a long time to get up to the right temperature for the solder paste to melt. Meanwhile, the SMDs, and especially the ASICs, are taking most of the heat directly from the hot air. That's why when people work on big boards like this, they usually use a reflow oven or a hot plate. With the BitaxeHex design, we pretty much have to do at least one side manually, unless we build a fancy jig so we can mount parts on both sides and then put the whole thing into a reflow oven. Anyway, I'm trying to do this just with the heat gun, and I can feel that the ASICs are not really floating on the solder, and this almost never works well, especially not for 6 ASICs in a row. I still finished reflowing all of them like this, and then I'll show you what I did to fix that problem. So my solution for this was to turn a normal cooking plate into a hot plate. First, I test the temperature with a laser thermometer and mark on the knob where the plate stabilizes at around 100 degrees Celsius and 150 degrees Celsius. Then I cut a 2mm aluminum sheet in a circle and put it on top of the cooking plate to make the heat more even. On top of that, I put a thick 1cm aluminum plate that I use as a base for my microscope. I add some T-shaped brackets to hold the microscope legs, and just like that, we have a DIY hot plate soldering jig. With this setup, placing all the SMD parts and then reflowing them is way easier. I go over all the parts one more time to reflow everything and make sure every pad is properly soldered. And now you can really see the ASICs floating when they reflow. That's how you know the solder is melted and making good contact. This setup is not really safe or ideal, and I will be making a much nicer jig in an upcoming video with a proper sliding work plate, a much safer setup, proper heat sensors, and a solid microscope mount. I actually burned my finger several times using this temporary setup, but luckily nothing serious. This little miner should push somewhere between 2.7 and 3.3 terahashes per second, while only using about 57 to 65 watts. And that gives us an efficiency of around 19 to 22 joules per terahash. To put that in perspective, the popular S9 back in the day was doing about 13 to 14 terahash per second, pulling around 1,300 watts with an efficiency of 95 to 100 joules per terahash. So yeah, 4 BitaxeHex boards running about the same hash rate as an S9 will only use around 240 watts instead of 1,300 watts. Thanks for watching. Don't forget to like and subscribe, and leave a comment if you have any questions or suggestions. Also, don't forget to check the link in the description, and big thanks again to Next PCB for sponsoring this video. In the next video, we'll be soldering the other side of this PCB and continuing the BitaxeHex build, so stay tuned.